Hello everyone, today we'll be going over Maths Paper 1, June 2021 for Matric Caps. So we'll get started with question 1, which is asking you to solve for x. The first question, 1.1, says solve for x if x squared minus x minus 20 is equal to 0. So here we put in our two brackets and determine what can give us 0. So the x squared has a coefficient of 1, so both brackets will simply get an x. Then you must determine which factors of 20 can give you -1. Looking at this, the factors 4 and 5 have a difference of 1, so those would be our factors. So then, since it's a -1, 5 is the bigger number. You will make the 5 negative and the 4 positive, so that your answer would be a -x. So it would be x minus 5, x plus 4. And therefore, our answers would be x is equal to 5 and x is equal to -4. Because if you substitute x is equal to 5 into that equation, you'll get 0 times 9, therefore, which is 0. And if you substitute -4 into that, you will get -9 times 0, which is equal to 0. Moving on to question 1.2. They ask us to still solve for x, but now we have 3x squared minus 2x minus 6 is equal to 0. For this one, there is no factors that work that we can solve for to get a round number. You can check this by doing the butterfly on the side. You would have 3x and x. The factors of 6 could either be 6 and 1, or 3x and x with 3 and 2, or 3x and x with 2 and 3. But either way, any way you work it, you cannot get a factor that works. Therefore, we are going to have to use the quadratic formula. So if we substitute, remembering that this is our A, this is our B, and this is our C, if we substitute it into the quadratic formula, we will get that x is equal to -2 plus minus -2 squared minus 4 to the 3 and to the -6 over 2 into 3. Now, if you plug that into your calculator, you can simplify the square root, the third, into a smaller number. By this, I mean you would say -2 plus minus, simplifying what's within the third to get 19. All of this would be over still your 2 times 3. Therefore, if you put this into your calculator, saying plus, you would get an answer. And if you say minus, you will get your other answer. The one answer being -1.12, or the other answer being x is equal to 1,79. Make sure you round off to the correct 2 decimal places as the instructions require. Moving on to question 1.3. You are asked to determine x when x minus 1 squared is greater than 9. For this, you need to first put it into your standard form that you can work with. This means that you should square the brackets, which means we can say x minus 1 times x minus 1 is greater than 9. So we need to now FOIL these brackets to get into the standard form. We would go first, so x squared, inners minus x, outers minus x, and lasts plus 1. Then greater than 9. Now we need to bring that 9 across so that we have a greater than 0. So this would give us x squared minus 2x plus 1 minus 9. Remember, when you bring it across, you need to change the sign, and this will all be greater than 0. This means x squared minus 2x minus 8 will be greater than 0. Now, to find our critical values, we need to simplify this again back into the two brackets. As we always do, you put your two brackets, and since the coefficient of x squared is 1, it will be x and x. Then factors of 8 that will give us 2 would be 4 and 2. And since it's minus 2, the 4 is the bigger one and needs to be the negative. Therefore, x minus 4, x plus 2. And this will also all be greater than 0. Now, you must state that your critical values are x is equal to 4. Since it's a negative in the bracket, you do the opposite sign. Or x is equal to minus 2. Now that you've stated your critical values, you need to figure out where on the spectrum they lie. So if you draw your line and you have your 4 and you have your 2, is it in the middle that makes the answer greater than 0, or is it on the outsides? If you plug in minus 3, you will get a negative times a negative, making it positive. And if you do a 1, you would get a negative. If you do a 5, you would get a positive. And you want greater than 0, so you want the positives. So, therefore, x must be less than negative 2, or x must be greater than 4. Another way of writing this could be that round brackets, since it's not included, it didn't say greater than or equal to, it only said greater than. So a round bracket, negative infinity until negative 2, or 4 until infinity, also round brackets. Then you can move on to question 1.4, which now asks us to also solve for x. 2 into the square root of x plus 6 plus 2 is equal to x. Now this one, you can't deal with it until you've got rid of that surd. But to do that, we need to take our 2 across so we can deal with them on opposite sides. So we take our 2 across, remembering to change the sign when our numbers cross the equal sign. Now we can put these into brackets and square them. So if we square each side, remember to distribute the 2 fully in the first bracket. Therefore, you would get 4 into x plus 6 is equal to, now we need to FOIL these again, which would give us x minus 2 times x minus 2. We need to now distribute the 4 into our brackets, giving us 4x plus 24 is equal to, now foiling again, 2x squared minus 2x minus 2x will give us minus 4x, and minus 2 times minus 2 will give us plus 4. Now we simplify whatever we can and bring them all to the same side. If we all take it to that side, what we will get is x squared minus 4x minus 4x, which would give us minus 8x, this 4x minus this 4x. And then you have plus 4 minus 24, which will give you minus 20 is equal to 0. Now we need to figure out what factors of 20 could we use in our brackets to give us the answer. So we have a 1, so it's x and x in each bracket. Now what factors of 20 have a difference of 2? Remember, we have 8 and we have 10 and 2 that could give you 20, and 10 minus 2 may give you 8. So the 8 is a negative, therefore the bigger number needs to be the negative. So you have x minus 10, x plus 2. Therefore, x may equal 10 or x may equal minus 2. But now, we need to make sure that our answer makes sense and make sure all of our answers are valid. So if we sub in x is equal to 10 into our original equation, we would get the square root of 16, 2 times the square root of 16, which would be 4 times 2, so 8 plus 2 is equal to 10, which means this would be a valid solution. However, if we substitute in x is equal to minus 2, you would have 4 under the square root, which would give you 2, times 2, which would give you 4, plus 2, which would give you 6, is equal to minus 2. That doesn't work. Therefore, remember to say this is not a valid solution by putting a cross through the equals sign. Moving on to question 1.2, we have to solve for the simultaneous equation. Here we can see that we have a common number or common thing between our two equations, namely the 4x. Therefore, we can use the cross-cancel method if we have them on opposite sides. So let's rewrite them together on opposite sides. We'll have 4x plus y is equal to 2, and 8 is equal to 4x plus y squared. We can see that the 4x's can cancel out, leaving us with 8 plus y is equal to 2 plus y squared. If we were to now put this into a standard form, you would have y squared minus y, bringing this y across, and that 8 across, leaving you with minus 6 is equal to 0. Now we just have to say y without brackets again. And what factors of 6 would give you minus 1? It would be minus 3 and plus 2. So y minus 3 and y plus 2 is equal to 0. Therefore, your options are y is equal to 3 or y is equal to minus 2. Now, we're not done because we also have to solve for x. So if you substitute y into one of the original equations, what are your answers for y? Into the original equation, generally you should choose the easier equation, which in this case would be this one. So if we substitute y into this equation, you would have 4x plus 3 is equal to 2. Which gives you 4x is equal to, take that 3 across, make it a negative, minus 1. X would be equal to minus 1 over 4. Or 4x plus minus 2 is equal to 2. 4x is equal to, take the 2 across, make it positive, 4, and x would be equal to 1. Therefore, these are your 4 answers for your simultaneous substitution or solving. Moving on now to question 1.3, we have to solve for x if it is given that 2x times 3y is equal to 24 to the power of 6. Now, the bases of these are not the same, but there is a way that we can make it the same. What are the factors of 24? 24 has a factor of 8 times 3. How else can we write 8? Or what are the factors of 8? 8 is also 2 cubed times 3. Now, we can rewrite 24 as that. So 2x times 3y is equal to 2 to the power of 3 times 3 to the power of 1 to the power, all of it, 6. Now to solve, we're going to have to distribute that 6 into the bracket. 2 to the power of x times 3 to the power of y is equal to 2 to the power of 3 times 6 to 18 times 3 to the power of 1 times 6, 6. Now do you see that the bases are the same? Therefore, 2x is equal to 2 to the power of 18 and 3y is equal to 3 to the power of 6. Therefore, x will be equal to 18 and y will be equal to 6. That's it for question 1. Question 2 asks us to solve for the quadratic sequence of 72, 100, 120, and 132. They've told us it is a quadratic sequence. Therefore, you know that the second difference will be equal. So let's figure out the differences between each and then their second differences. So between the first two numbers, the difference would be 28. Between the second two, it would be 20. And between the last two, it would be 12. So now between these numbers, the difference would be minus 8. And the difference would be minus 8, which makes sense since they told us it was quadratic. Now we need to solve for Tn is equal to an squared plus bn plus c. Now we need to figure out what all of those values are. But remember, we know that 2a is equal to the second difference, which in this case is minus 8. Therefore, a is equal to minus 4. We also know that 3a plus b is equal to the first difference, which in this case is 28. It's the first difference between the 72 and 100. If we solve this by substituting in the a that we've already solved, we would have 3 times minus 4 plus b is equal to 28. Therefore, b would be equal to 28, and then 3 times 4 would be minus 12. If you took that minus 12 across, it would be plus 12. Therefore, b is equal to 40. Now, to solve for c, we know that a plus b plus c is equal to the first term. Therefore, a plus b plus c is equal to 72. A we know is minus 4. B we know is 40. C we do not know, and that is all equal to 72. Therefore, C is equal to 72 plus 4 minus 40. C is therefore equal to 36. Now we must rewrite all this information together. Tn would be equal to minus 4n squared plus 40n plus 36. And that would be our answer for question 2.11. Moving on to question 2.12. Here they ask us to find, or they tell us that a term in the quadratic sequence is equal to the 12th term of the sequence of first differences. We must determine the position of this term in the quadratic sequence. So basically what they're explaining here is that if you look at this, at the 12th term here will be equal to an nth term here. And they want you to figure out what that term number in the sequence is. So if we're looking at this would be a whole new sequence with T1 being here, T2 being here, and T3 being here. So before we do anything there, we need to figure out T0 and then figure out the 12th number from there, and then we can move backwards there. So what would T0 be in this equation? It would be something, it would be 28 plus 8. So we know that T0 of the first sequence differences would be 28 plus 8, which would give you 36. And now they told you that the 12th sequence of the first difference is equal to this number. So T12 of 36 minus 8n is equal to our position or our number in the quadratic sequence. So now we substitute this 12. You say what is equal to 36 minus 8 to the 12? This will give you 36 minus 96, and that gives you minus 60. So now we want to figure out the position in the quadratic sequence that this minus 60 fits in. Basically, where on this would minus 64? So how do we calculate this? We basically take our formula Tn is equal to minus 4n squared plus 40n plus 36 that we had previously calculated and make that equal to our minus 60. Now we just need to solve for n. So, we have minus 4n squared plus 40n plus 36 minus 60 is equal to 0. We can simplify this to minus 4n squared plus 40n plus, that should be a plus. Since we took it over, that 60 is now a plus. Plus 96 is equal to 0. Now these are big numbers to deal with, so we should take out a minus 4 to simplify these numbers we're dealing with. So if we take out the common factor of minus 4, we will be left with n squared plus minus. So now if you're taking out a negative 4, your signs all change. It's now a positive n squared minus 10n minus 24. And that will all be equal to 0. Now you need to figure out what factors of 24 can give you minus 10. Factors that come to mind should be 12 and 2. And since 10 is a negative, the larger number should be the negative. So now we have, you cannot drop that minus 4. You have n, and in your other bracket, you will also have n equal to 0. And we said 12 and 2, with 12 being negative. So you have n minus 12 and n minus 2. Therefore, it's either, the answers are either equal to n plus 2, So t is equal to 12 or t is equal to minus 2. And t cannot be equal to minus 2. Therefore, your answer is that Tn is equal, the term number is equal to 12. We then move on to 2.1.3. And in this question, they ask us to determine the maximum value of the quadratic sequence. But luckily, we have a formula to figure out the maximum value of a quadratic sequence. And this formula is minus b over 2a. Minus b in our equation was, our b is 40, so it's minus 40 over 2 times a, which is minus 4. This would be equal to minus 40 over minus 8, giving you a positive 5. Now, that is not the maximum value. That is the term number of the maximum value. Therefore, we need to now substitute this into our original formula that we calculated. So, T5 would be equal to minus 4, 5 squared plus 40 to the 5 plus 36. This will give us the answer of 136, which will be our maximum value of the quadratic sequence. Moving on to 2.1.4, they now ask you to consider the maximum value of a different sequence. This sequence is minus 2, 23, 5, 25, and 37. So now let's figure it out. It has a difference here of 28. Here we have a difference of 20, and here we have a difference of 12. Again, we have a second difference of minus 8 and minus 8. Now we have another quadratic sequence, and the value here is they're only asking for 1 mark, so it's a lot simpler than figuring out the whole formula and determining from there using our formula of minus b over 2a. Here we can see that if we took another minus 8, you would have only, so these are positives, plus, plus, plus. You would have plus 4. But if we took just one more, minus 8, as a difference, you would have suddenly, between the next two numbers, a minus 4, which means your sequence would start decreasing. So if we figure out these numbers, we can figure out the maximum. 37 plus 4 would be 41. But now 41 minus 4 would be 37. And so now we see that the first difference, is starting to become negative. Therefore, our maximum answer is over here. So this is less and that is less, which means that is our maximum. Maximum value is equal to 41. Moving on to question 2.2. They say, consider the sequence of 11, 2 sine 3x, and 15. They tell you that you must determine the values of x in the interval of 0 to 90, for which the sequence will be arithmetic. Now, since they've told us about this, that the sequence is arithmetic, you know that the third one, our third minus our second, will be equal to our second minus our first. So we know that 15 minus 2 sine 3x will be equal to 2 sine 3x minus 11. If we now simplify this, you bring your 11 across and you have 15 minus 11 is equal to 2 sine x 3x plus 2 sine 3x. Therefore, we have that 4 is equal to 4 sine 3x. We can now simplify this further to divide the 4's, which will give us 1 is equal to sine 3x. What do we know in our sine tables about sine is equal to 1? What value of sine is equal to 1? If you draw out your trig tables, you will know that sine 90 is equal to 1. Therefore, you can say that 90 degrees is equal to 3x. Therefore, if you divide both sides by 3, you will get that x is equal to 30 degrees. Moving on now to question 3, we are told that r is equal to 1 over 5 and a is equal to 2,000. Question 3.1.1 asks you to determine Tn, the general term of this series. Based on the information we are given and our formula sheet, we know that we're working with a geometric series. And all you have to do is substitute in the values you are given into the general formula you know. The general form here would be Tn is equal to a times r to the power of n minus 1. You're given r and a, so you just substitute in the values that you are given to give you the answer of 2,000 times 1 over 5 all to the power of n minus 1. And that would be your final answer for this question. Question 3.1.2 now asks that you determine what the value of T7 is. Since you know the general form from the previous equation, all you need to do is substitute 7 into the place of n. So T7 would equal 2,000 times 1 over 5 to the power of 7 minus 1. That's basically saying 2,000 times 1 over 5 to the power of 6. Now, all you need to do is put that into your calculator and you will get an answer of 16 over 125. Also, just a one more question, simple, and that is your answer. Moving on to question 3.1.3, we are now asked to determine which term of the series will have a value of 16 over 15,625. Now, this is asking for you to determine n, which number has this value. So all we need to do is use our original form of Tn is equal to 2,000 times 1 over 5 to the power of n minus 1. You now know that Tn is equal to 16 over 15,625, which is equal to 2,000, 1 over 5 to the power of n minus 1. Now you just need to determine the value of n. To do this, we need to take our 2,000 across. So if we divide both sides by 2,000, if you just simply do this on your calculator, you'll see that that cancels with that. And this left-hand side will give you a value of 1 over 1953125. And that is now equal to 1 over 5 to the power of n minus 1. At this point, you can choose which method suits you better. You can either log all of these values to give you a result of n minus 1, or you can see if you can find a common base. In this case, if we put the 1,953,125 into our calculator, we will see that there is a common base. That 5 to the power of 9 is also equal to 1,953,125. Therefore, we can say that 1 over 5 to the power of 9 is equal to 1 over 5 to the power of n minus 1. Now that we have common bases, we can drop our bases and work with only our exponents, which would mean 9 is equal to n minus 1. Therefore, n is equal to 10. Because remember, when we take our minus 1 across, it becomes a positive 1. If you want to see our alternative method, you can also use logs. So now, when you're changing this form into a logarithmic form, you have to remember that your exponent over here is the answer you want to get. So now we say n minus 1, you're simply changing the form, is equal to log. Our base stays our base, so our base stays our base, and then we put our answer, 1 over 195,3125. If you put that into your calculator, you will also get that n is equal to 10. Both should give you exactly the same answers. And if you do one method and you want to check that you had not made any other mistakes, you can always do the other method as an assurance or check to make sure you got the answer correct. Moving on to 3.2, they say, consider the geometric sequence of n equals to 1, Tn is equal to 27, where S3 is equal to 26. They ask you to calculate the constant ratio R of this series. Now we have formulae for these kind of series. One of the formulae we have is that the sum of the series is equal to A1 minus R. The other one that we have is that S with a number is equal to A Rn minus 1 over R minus 1. However, we know which number we are dealing with, therefore we could substitute 3 into n. S3 is equal to A R to the 3 minus 1 over R minus 1. And we know that that is equal to 26. We also know that this is equal to 27, A1 minus R. Now, if we can solve to make this equal to this, we can then substitute in these two formulae to find an answer for R. Now, because we don't know A, and we have two variables, therefore we need to get rid of A. We see that if we take out a negative in this 27, in the 1 minus R and make 27 negative, we can get this side to equal this side. To make it easier, let's rewrite this side so you can see it. It is the same as writing A over R minus 1 times R3 minus 1. That is the same format as the previous, but now you can isolate this and see that they are very similar. However, they are not quite identical yet, as R minus 1 is not the exact same thing as 1 minus R. Therefore, if we take out a negative on this side, we will get 27 equal to minus R minus 1 and A. Do you see that if we take out a negative here, you would make it negative 1 and plus R, which is the same as saying R minus 1. Now, if we take this negative across and make it a negative 27, A R minus 1, we can see that this is identical to this, and therefore we can substitute. We can say that negative 27 times R cubed minus 1 is equal to 26. Therefore, R cubed minus 1 is equal to negative 26 over 27. Therefore, R cubed is equal to negative 26 over 27 plus 1, which will give us a positive 1 over 27. Now, if we cube root both sides, we would get an answer of R is equal to 1 over 3. R is 1/3, and that is your answer. That is what they had asked you to solve. So now that is question 3.2 done. Moving on now to question 4. We are now moving on to functions. They tell you that the lines y is equal to x plus 1 and y is equal to minus x minus 7 are the axes of symmetry of the function f of x is equal to minus 2 over x plus p plus q. We must make sure we are understanding what we are dealing with here. Looking at the f of x here, we know that we are dealing with a hyperbola, and they've given you the axes of symmetry. So now let's see what question 4.1 asks. It asks that we show that p is equal to 4 and q is equal to minus 3. So here they are basically asking you to find the standard form of the hyperbola. Now all the information you're given are the axes of symmetry. How can we use those to determine our p and q? Well, if we equate our two axes of symmetry at the point that their y's are the same, we can figure out x, substitute back in to figure out y. Because remember, when we have our hyperbole, well, we know it's in quadrant 1 and 4 because it's a negative. You have your two axes wherever they are, but they'll meet at a certain y value. So if we equate our two equations, we can figure out what y value it is that they meet at. Now, let's equate. We will say that x plus 1 is equal to minus x minus 7. So take the x across. X plus x will give you 2x. Take the 1 across, minus 7 minus 1 will give you minus 8. X is therefore equal to minus 8 divided by 2, minus 4. Now, if we substitute that minus 4 back into one of the equations, y is equal to minus 4 plus 1. Y will be equal to minus 3. Now, that is not our answer, final or completed. We need to just substitute it back into our f of x to understand what p and q are rather than what x and y are. F of x, we are told, is equal to minus 2 over x plus p plus q. Therefore, f of x is equal to minus 2x plus 4 and q minus 3. Don't forget to change that sign of that minus 4 since they've told you it is plus q, plus p. Okay, and then that would be our final answer, saying that p is equal to 4 and q is equal to minus 3. Now, moving on to 4.2, the question now asks us to calculate the x-intercept of f. How do we calculate x-intercepts? Well, x-intercepts, you always let y equal 0. And for y-intercepts, you always let x equal 0. So now if we let y equal 0 in the equation that we know, you would have f of x, which is y, which is equal to minus 2 over x plus 4 minus 3, which we had previously calculated, and you let that equal 0. So 0 is equal to minus 2, x plus 4 minus 3. What can we first do? Well, we could take the 3 across and make it a positive 3, but you don't have to write that positive, and is equal to minus 2 over x plus 4. Next, we can times both sides by x plus 4 to give us 3 into x plus 4 is equal to minus 2. Therefore, 3x plus 12, if we distribute our 3 into our brackets, is equal to minus 2. Right? Now, if we take that minus 2 across, or we can take that 12 across. So if we take the 12 across and say 3x is equal to minus 2, minus, because we need to change our sign, minus 14. Then we divide both sides by 3. We will get that x is equal to minus 14 over 3. And there's your answer. They had not asked you to calculate anything else. The x-intercept of this specific graph will be minus 14 over 3. Question 3 now asks you to sketch the graph 4.3. So now if we have our axes, it's best to figure out all the information you're going to plot on this. They have asked for your asymptotes and for your axes intercepts. Your asymptotes will be Q and minus P. So Q will be your horizontal asymptote, which is equal to minus 3. And your P will be your vertical asymptote, which would be equal to minus 4. Now that we have that, we need to figure out our axes intercepts. We have worked out our x-intercept is equal to minus 14 over 3. That's a bit of a difficult number to interpret, so we can also write it as a decimal, minus 4.66. Our y-intercept we must calculate. So now how would we do that? By making x equal to 0. If we plug that into our equation that we had previously done, which is f of x is equal to, let's just rewrite it, minus 2x plus 4 minus 3. If you plug 0 into there, you will have that y is equal to minus 3.5. So now that we have all our points, we can plot them on our graph. An important point, you should do this to scale. If 4 is over here and 4.6 is over there, 3 minus 3, sorry, don't forget your negatives, and minus 3.5 is over there. We also know that our A here is negative 2, meaning we will be in quadrant 1 and quadrant 4. That is something you should always learn and know well. So we know that our asymptotes will be at minus 4 and our horizontal asymptote will be at minus 3. It's important that your line almost touches the asymptote, but never actually does. So we almost touch our asymptote, we go up through our intercept, and we almost touch our next asymptote. The same here, we almost touch our asymptote, but we never do. So please draw that slightly neater, remembering to do your axes with proper spacing and measurement. And then you should have a graph that looks like this, but slightly neater, making sure the shape is correct, that you are in quadrant 1 and 4 because your A is negative, that you show your intercepts, and that you show your asymptotes and their values. Now we move on to question 5. Question 5, we are still dealing with functions, and they have drawn a graph that looks something like this. With a second function going like this. This straight line graph is g of x, and this graph quadratic is f of x. This point is point A, this is point B, and this is point C. Alright, so we have been told that f of x is equal to minus 2x squared plus 4x plus 16. And g of x is equal to 2x plus 4. A and B, we have been told, are the x-intercepts of f of x, and C is the turning point. Now, these are things we can see, we know how to calculate, and we'll probably need later. But first, let's look at the questions. 5.1 asks us to determine the coordinates of A and B. And as they have said, these are our x-intercepts. How did we say we can determine our x-intercept? By y equals 0. So if we take our f of x, making y 0, you will have 0 is equal to minus 2x squared plus 4x plus 16. Now we just need to solve this like we would any other mathematical question. First of all, you can see a common denominator between all of these, which would be negative 2. So to make this a bit easier to solve, let's take out our negative 2. Remember, if you're taking out a negative 2, all the other signs need to change. So this would be minus 2x and minus 8. Now we need to solve these. Which factors of 8 would give us minus 2? It would be 4 and 2. And since our 2 is negative, the larger number needs to be negative. Therefore, you will have x minus 4 and x plus 2. Therefore, x is equal to 4 or x is equal to minus 2. Therefore, we have to write out our coordinates properly. A would be equal and B would be equal to what? Make sure you get this order correctly as it makes sense on the graph. We can see here that A is on the negative side of the graph and B is on the positive side of the graph. Therefore, your positive answer will be B and your negative answer will be A. A will therefore be minus 2 and 0 since we let y equal 0, and B will be 4 and 0. And those will be your two x-intercepts. Moving on to question 5.2, they ask you here to determine the coordinates of C, which is your turning point. Now remember, for turning point, we actually have a nice formula. We have the formula of minus b over 2a. This is your turning point, and all you need to do is substitute into this formula. If we have our f of x is equal to minus 2x squared plus 4x plus 16, we know that this is our a, this is our b, and this is our c. Therefore, minus b would be minus 4 into 2 times minus 2, which is our a. Therefore, our turning point will be x for x will be equal to 4 times minus 4 times 2 times minus 2 will give us a 1x point. Now, they want the turning point and not just the x turning point, they want the full coordinate. How will we get this? By substituting this x back into our original equation. Therefore, you get y is equal to minus 2, 1 squared plus 4, 1 plus 16. Now, we know that this would be minus 2 plus 4, which would give us plus 2, plus 16, which will give us y is equal to 18. Now, your coordinates, your turning point, C, would be equal to your x is always written first, 1 and 18. And that would be question 5.2 complete. Moving on to 5.3, they want you to write down the range of f of x. Now remember, range refers to your y-axis and domain refers to your x-axis. So what would the range of this graph be? Looking at this and you're considering your y-axis, what would the range be? Well, we can see that it is a sad face, so your range would be going down to infinity and have a maximum point at point C, which we have just calculated. There are various ways of writing this down, one of which being saying that y is less than or equal to 18. Another way you could say is y negative infinity until 18, including 18, since it is y is equal to or less than. Those are the two ways you can write it. Either are 100% fine. But do you see that we go from negative infinity or anything less than 18 up until and including 18, since our graph is upside down. 5.4 then asks us, if the graph of h of x, which is x of x, f of x plus p plus q, has a maximum value of 15 at x is equal to 2, determine the values of p and q. So now this graph has just been transformed. It has been moved and some values have changed. However, you know the maximum value is now 15. And what was the maximum value previously? The maximum value previously was 18. So therefore, we have moved down 3 points. We have moved down 3 units. Also, they tell you that this was at x is equal to 2. Previously, our turning point was at x is equal to 1. So now the difference, the transformation, is that we went from 18 and 1 to 15 and 2. We have moved our graph down and 1 unit to the right, down 3 units and 1 unit to the right, because there is a difference of -3 here and a difference of +1 here, which is down 3 to the right 1. How we would write this in accordance to P and Q is that it would be P is -3 because we went down 3 units. And now the one to always remember is, even though we added 1, this is Q. P is always the opposite sign. You added 1 and you shifted right. But P, when you take it out of the standard form, changes sign. So here we need to change sign again. It would be P -1, since you shifted right 1 unit. Always remember, shifting right, even though you're adding 1 on the x, is a P -1 because you change the sign because your turning point formula is -PQ. And therefore, whatever the sign is here for Q, you keep the same here. But for P, whatever it is here, you change in the opposite because of this for here. And therefore, our values are Q is equal to -3 and P is equal to -1. Moving on to question 5.5, they now ask that we determine the equation of g to the -1, which is basically the inverse of g. They want this in the form of y is equal to. Now, we know that g was given as 2x plus 4. And now they want the inverse of that. How would we do that? A simple way of determining, let's just write this as y and x's. A simple way of doing the inverse is simply by swapping your x value and your y value. So if we now swap those and write it as x is equal to 2y plus 4, we have now done inverse. But they have specifically asked that we write this in relation to y is equal to. So now we need to isolate this y variable. How will we do that? By our normal mathematical methods. X, and if we take this 4 across, we have to change its sign. X minus 4 is equal to 2y. Now we still need to isolate that y, and I'm just going to switch the order I write it. I'm going to say that, and now we're going to divide both sides by 2. I'm going to say that y is equal to x over 2 minus 2. So I've separated where the denominator is. And I've said x over 2 minus 2. This can also be written as y is equal to a half x minus 2. They are both saying the same thing. This last one just looks like a better form of writing it. Moving on now to question 5.6. They ask us for which values of g to the negative 1, so our inverse g times our g equal 0. So now you have two equations, and you just need to make one of them equal to 0. So when you times g to the negative 1 times g to the x, how can you get that to equal 0? Well, you either need that to equal 0 or you need that to equal 0. So basically, they are asking you what makes y 0. If you look at your equations, it is a half x minus 2. And your initial equation was 2x plus 4. Now, it is a simple sum, like we have always done. How can you make this bracket equal to 0? Well, you could say a half x is equal to 2. Take that 2 across, and x would be equal to 4. If you times both sides by 2, you would get 4. If you did this bracket to make 0, and you divide now both sides by 2, you would have x is equal to minus 2. So the product of the zeros at the x-intercepts would give you 0. All they are asking us is, how can you make it equal to 0? You equate either of the brackets to 0 and get a result, and there you would have made the equation 0. Moving on to 5.7, they ask if p of x is equal to f of x plus k, determine the values of k for which p and g will not intersect. So if p of x, a new graph, is equal to f of x plus k, a transformation, what values of k, how can we transform that graph that p and g of x will not intersect? So if we draw this graphically, looking at our original graph, here f of x and g of x are intersecting at 2 points. So they have asked now, how could we shift this graph up or down to make sure it does not intersect? Can you see that if we redraw this graph and shift it, if g stays the same, and we shift this graph down so that our maximum value, our turning point, is so low that it never intersects with g of x, that these will not intersect. Therefore, k needs to shift our graph down enough values that they never intersect. And we need to determine what those values are. So how we would approach this is by saying by adding a k and determining what value for k that would be. So if we can figure out the lowest point, we can go below that. If we can determine what point that would be, that the last point touches, anything where the graph is slightly lower would be our answer. So how we write this out mathematically, how we shift this graph down and figure out what maximum point can we put it that it does not intersect, is by adding k in the formula and figuring it out from there. So here we will have f of x, which is our negative 2x squared, plus 4x, plus 16. But now we need to add k and equate it to g of x. So equating it usually finds the intersection where they touch. But now you want to figure out where they don't touch. So if you figure out this and then say anything below that, you will have your answer. Now, if we do our normal maths and take our 2x plus 4, across, we will now have minus 2x squared plus 4x minus 2x gives you plus 2x, plus 16 minus 4 would give us plus 12, plus k is equal to 0. Now you know the formula to determining our basics is our maximums is b squared minus 4ac is less than 0. This is our formula we need to know. And now we need to substitute into this formula where this is a, this is b, and this is c. Now we substitute in. B is 2 squared minus 4 minus 2 plus 12 plus k. Don't forget that your c is your last unit, and it includes both of them because that is what you're trying to figure out. You cannot lose the k, otherwise you will not be able to solve. Now if we simplify this, 2 squared is 4. Minus 4 into this minus 2 will give you positive 8 into 12 plus k is less than 0. Now we need to distribute again, and we will say that 4 plus distributing this 8 into both, 96 plus 8k is less than 0. 100 plus 8k is less than 0. Now if we take our 100 across, we will have 8k is less than negative. Remember, when we're changing sides, you change the sign, and divide both sides by 8 will give you negative 12.5. So basically, they're saying that k needs to shift the graph negative 12.5 units down to make sure that these graphs do not intersect. I hope that all made sense, that the graph moved 12 units down so that they did not intersect. Remember, it has to be down, so it makes sense that our answer is negative, because if our graph moved up 12 units, it would still intersect at some point, because these two go down to infinity. So our graph has to move down so that these will never intersect. Moving on now to question 6.1. You are given that g of x is equal to 3 to the x. Now we know we are dealing with an exponential function. We know this, and now certain things should come to your mind, like a bottom asymptote. The first question, 6.1.1, asks us to write down the equation of g to the minus 1 in the form of y equals. This is once again them asking us to write the inverse. How did we do the inverse previously? We swapped our y and x, and this is basically saying y is equal to 3x. If we swap them around, x is equal to 3y. But they have asked that we write it in the terms of y is equal to. So how would we swap this around? We would log our answer. How do we do this? Well, you know y needs to be the answer. So y is equal to log, our base stays our base, 3, and then our previous answer becomes there. It is always in that formula. Our exponent here becomes our answer, log, our base stays our base, and x moves that side. And that would be your equation of the inverse of g. 6.1.2 we now move on to, and they ask if point P, which is 6 and 11, lies on h of x, which is equal to 3x minus 4 plus 2. The graph of h is translated to form g. Write down the coordinates of P on G. So now they have asked you what the coordinates of P are if it is on G. How has it transformed? So remembering our G of x was simply 3x. What is the difference between these two? What was the transformation that happened here? The transformation was 4 units and 2 units. So now you need to figure out which direction these 2 units went and how you can figure out P from the transformation. So the minus 4 indicates that indicates a transformation 4 units left, and the plus 2 indicates 4 units down. So if we look at this, we moved from one to the other 4 units left and 2 units down. And this is going from this one to this one. If you went the other way and you were transforming it from g of x to h of x, it would be 4 units right and 2 units up because it's plus and negative. But we are going the other way, so it is 2 units left and 4 units left and 2 units down. Now, how do we figure out P without any values? Well, we know we went 4 units left. So our 6 reduced by 4 units. And we went 2 units down. So our 11 reduced by 2 units. Therefore, P would be equal to 6 minus 4, which is 2. And our Y would be equal to 11 minus 2, which would be 9. And that's how you would solve question 6.1.2. You see the difference in these, and you figure out the direction, and then you rewrite the units by the difference. Remembering that this is not like the hyperbola, negative and positive, meaning it is 4 units left and 2 units down. Moving on to question 6.2. Okay, so in 6.2, we're given this graph and asked now, and we're also told that the graph of f of x is equal to 2 to the power of x plus p plus q. Again, we have an exponential graph. The point T is at x 3 and y 16, with the asymptote being minus 16. Now, question 6.2 asks us to determine the values of p and q. Right off the bat, you know from your standard forms that q is equal to the asymptote. Therefore, q is equal to minus 16. Now, if you're looking at this formula, you have three missing variables, x, y, and p, because you have determined q. But they've also given you the point t. So you can substitute those values into the y and x values and then determine your p value. So if we write it out in the form y is equal to 2x plus p minus 16, we just need to substitute in our x and y values. X being 3, y being 16. So 16 is equal to 2, x, which is 3, plus p minus 16. Now, if we simplify this, we take our 16 on the right-hand side across, and we add it to the other 16, which gives you 32 is equal to 2 to the power of 3 plus p. Now, we need to find a way to solve this. There is multiple ways in which you can do it, but generally the easiest is to try find a common base. Now, what are the factors of 32? Well, one of the factors will give you 32 with a base of 2 to the power of 5. This you can find on your calculator, but the factor of 32 is 2 to the power of 5, which will then be equal to 2 to the 3 plus p. Now that we have our common base, both of them being 2, we can drop our bases and work only with our exponents. Therefore, 5 is equal to 3 plus p. Therefore, p is equal to 5 minus 3. Take that across and change the sign to a negative. Will give you p is equal to 2. And there you have your two values, which it's always good practice to rewrite into your equation of 2x plus 2 minus 16. And that is it for question 6. We move on now to question 7, which is our finance question. In question 7.1, they tell us that amount of 10,000 Rand was invested for 4 years, earning at a rate of R% per annum, compounded quarterly. At the end of the 4 years, the total amount in the account was 13,080 Rand. Now you need to determine what the value of R was, i.e., what was the interest rate you were earning. So now we have to go to our formula sheet and look for our formula. We know that we have a formula that states that A is equal to P, our initial amount, into 1 plus I to the power of n. So now we just need to substitute in to our formula correctly. Our A is our final amount at the end of our time. So our 13,080 Rand is equal to our initial 10,000 Rand, which we invested, at an interest rate we do not know, but we know that it was compounded quarterly. So it's I over 4 to the power of 16. So those are all values that we had gotten. Remembering how to calculate 16, we have 4 years times 12 months, which will give us 48. But we are not earning interest every single month. We are earning interest quarterly, which means every 4 months. And since there are 12 months in a year, this means we are earning interest every third time. So 48 divided by 3 will equal 16. Make sure to get that correct. Moving on, we can now divide each side by 10,000. And this will give us a result of 13,880 divided by 10,000 to have 1 plus I over 4 equal to 1,308. And that you can simply just do on your calculator. Now we need to get rid of our exponent here, so we'll take all of those to the power of 16. And then we will get an answer. So if you just put that into your calculator, you should get an answer of I over 4 is equal to answer of 1,01692. Then you take your minus 1 across. I over 4 will equal 0,1692. 0. And then you times both sides by 4. Your I will equal 0,06769. Once again, just plugging it into your calculator. Now that is the value for I, and if you want the percentage of the interest rate, you times that by 100, and I will equal 6,77%. Moving on now to question 7.2. They ask you and tell you that a businesswoman deposits 9,000 Rand into an account at the end of January 2014. She continued to take monthly deposits of 9,000 Rand at the end of each month up until the end of December 2018, i.e. including December 2018 and excluding January 2014. The account earned at an interest rate of 7.5% per annum, compounded monthly. Calculate how much money was in the account immediately after 60 deposits have been made. So they have told you how many deposits had been made, and they want you to calculate how much money was in the account after the 60 deposits. So for this, we need to find our formula on our formula sheet and write it out. So for this, we will have how much was made at the end is equal to our monthly deposits into 1 plus our interest rate, 2n, compounded monthly, minus 1, all over our interest rate. Now we just need to substitute in all the information we have. We have been told that X, our monthly deposits, is 9,000 Rand, into 1 plus I, our interest rate, which was 0,075 over 12 months, compounded, and 60 deposits were made, minus 1 all over 0.075. Don't forget to change that into a decimal, because it is, unless you're going to write percentage on your calculator, it is just safer to turn it into a decimal, which you do by dividing by 100. And since it is compounded monthly, we put it over 12. Then you simply put all of that information into your calculator, and you should get an answer of RF equaling R652,743,95. Remember always to round off to 2 decimal places since we are dealing with money, and that is how we do rands and cents. Moving on now to 7.22. They want you to know, for the same situation of depositing 9,000 Rand into account, the businesswoman left the amount calculated for a further N months in the account. The interest rate remained unchanged, still 7.5, and no further payments were made. The total interest earned over the entire investment period was 190,214.14 cents. Now you need to determine the value of N. Please read the question carefully. The 190,000 was not the interest earned after what we had calculated. It included the interest earned while we had calculated. So the interest earned in our previous calculation we can determine by saying 9,000 times 60 deposits, which gives us a value of 540,000 Rand. Now, we can use our formula again to figure out the number of months that she continued to earn interest without adding any deposits. So if we look at our formula again, A is equal to P 1 plus I to the N. We know our final amount of A is equal to the 540 she invested plus the 190,214 cents that she earned in a total of all her investments. This would be then equal to the amount we're starting off with that we got from our previous equation of 652,743,95. So that's where she left off and stopped depositing. We want to figure out how she got to the total amount. How many months more was she earning interest? So now you put plus 1 plus 0.075. The interest rate remained the same, still compounded monthly, to the power of N. Now we need to determine N. First of all, we need to calculate how much the 540 plus 190,000 is to give us a total number of 730,214.14 cents, which would be equal still to the 652,743.95 cents, still with 1 plus 0.075 over 12 to the power of N. Now you can divide both sides by the 625,014 cents, both divided by 652,743.95, which will give you a value of 1.11868 is equal to 1 plus 0.075 over 12 to the power of N. Now we need to log both sides, remembering how to log. The answer is N. That is what you are looking for. Log, keep your base of 1 plus 0.075 over 12 times your upper number would be your 1,11868. If you put that into your calculator using the log function, remember not to use the log natural base 10, use the log button that has two numbers. N should give you 18 months. And that would be your final answer. So the businesswoman put in 9,000 Rand every month and earned interest quarterly. Then she stopped putting in deposits and carried on earning interest for another 18 months to bring her to the grand total of 730,000 Rand, 730,214 Rand and 14 cents. And that would be it for question 2. There is another alternative method you may use to solve that by figuring out the interest and the difference. Either answer is perfectly fine as long as you get to 18 months. Moving on now to question 8. We are going to be determining f of x from the derivative of f of x from first principles, given that f of x is equal to 3x squared. So f of x is equal to 3x squared. And now from first principles, they tell you, you must determine the derivative of f of x. So you have to write out how your first principles are going to work. Remember, your first principles are using limits. So f derivative x will be equal to limit h to 0, f of x plus h minus f of x all over h. Remembering that equation is very important, and now we have to substitute. So f derivative x is equal to limit as h approaches 0. Now you need to make sure your substitution is correct. Every time you see x, you need to substitute what is said in the formula. In the formula, it says when you see x, you substitute it for x plus h. So first we go 3x plus h squared. The next one we minus simple f of x, so minus 3x squared. Then the bottom one is just h, and now we must solve. F of derivative x as the limit approaches 0. You have, first of all, you need to FOIL the x plus h, and then you need to put in the 3. So you would have 3 into x squared plus 2x h plus h squared minus 3x squared all over h. To simplify this further, you would say 3x squared plus 6xh plus h squared minus 3x squared over h. Simplified one more time. You see that the 3x squared and the 3x squared cancel each other out. You are just left with 6xh plus h squared over h. Then we can take out a common factor where we can say the limit as h approaches 0. We have a common factor at the top of h, left with 6x plus h over h, in which we can cancel those. Now that we can see that there is no further substitution we can do, we substitute in h is equal to 0, so it would be 6x plus 0. Therefore, f of derivative x is equal to 6x. And this answer makes sense if you think about it not from first principles. If you were to do it the quick way, 3 times 2 would give you 6, 2 minus 1 would give you 1, and that would also give you 6x. So that's a quick little check that you can do to make sure your answer was correct. Now we move on to 8.2.1. In this question, we are asked to determine f of derivative x if f of x is equal to x squared minus 3 plus x over 9 over x squared. In this question, they have not asked you to use first principles, so you can simply use the quick method, remembering that the quick method goes like this. Whatever your exponent is here, you multiply it by the coefficient in the front first. Then secondly, you take that number and minus 1 from it and leave that as the coefficient. So for this example, the answer would be 3x squared. Now using that principle, let's see if we can answer this question. If f of x is equal to x squared minus 3 plus 9 over x squared. First, we would want to take this and take it out of fraction form. How we would do that is to say x squared minus 3 plus 9. And now if we bring the x to the top, if we bring the x to the numerator, what happens to our exponents? If you ever swap from the numerator to the denominator or vice versa, your exponent becomes negative. And then it is saying the same thing. Now we can start doing the derivative. F of derivative x would be 2 to the front and then minus 1 would give you 2x to the 1, and you don't have to write the 1. 3 has nothing, so that just gets removed. Plus minus 2 times 9 would give you a negative 18x, and now you minus 1 minus 3. So therefore your answer would be 2x minus 18x to the negative 3. Moving on to 8.2.2, they want you to determine the derivative of gx. If gx is equal to x square rooted plus 3 times x square rooted minus 1. Now again, we should write this in a format that is easier to understand. Using a square root is not the ideal form. How do we change something from in a square root to become outside of a square root? Well, the square root of x is the same thing as saying x to the half. X to the half plus 3 and x to the half minus 1. So now we need to multiply out these two brackets to get g of x equal to x by firsts plus 2x to the half minus 3. So we just simply FOILed out our brackets. X to the half times x to the half just gives you x. Plus 3x to the half minus 1x to the half gives you 2x to the half. And plus 3 times minus 1 gives you minus 3. Now we can finally derive to say g to the derivative x is equal to what would x, this x has a 1. So 1 times 1 is 1. 1 minus 1 is 0. So you will just be left with 1. Plus 2 times a half is 1. And then x, you minus this now gets a minus 1, which takes it to minus a half. And the 3 has no x, so that will just fall away. Now this is not, you can either leave it at this form to say 1 plus x to the half, or you can put it into a form of 1 plus the square root of x. Either way is fine. Moving on now to question 9, we are asked, we are given a graph of f of x is equal to 2x cubed plus 3x squared minus 12x, and they have sketched it for us over here. It looks something like this. Okay. So it has two turning points at A and B and goes through the circle center at O. They have also given us a point C at 2 and 4. This is the y-axis and that is the x-axis. So they are asking in question 9.1 to determine the coordinates of A and B. The coordinates of A and B are the turning points of this graph. And how do we determine the turning points of a graph like this given this equation? Well, first you need to do the derivative of f of x. They do not ask you to use first principles here, so you may use the quick method. As per usual, we do it like this. 3 times 2 gives us 6. X, and then the 3 minus 1 is squared. Plus 3 times 2, which is 6. X, 2 minus 1 is 1. You don't have to write that. Minus x, there's a 1 here. 12 times 1 is 12. X minus 1, 1 minus 1 is 0, so x falls away. And that is our derivative. Now what you have to do is solve for x. We do this as we do all our other trinomials, where we put our two brackets. But before we do that, we can see that there is 6, 6, and 12. All of those have a common factor of 6, which we can take out to make our solving that much simpler. So if we take out our common factor 6, we will be left with that. Now we can put our two brackets, x and x. What factors of 2 will give me positive x? 2 and 1 are my only factors, and because x is positive, the large number 2 should get the positive. X plus 2, x minus 1. Therefore, x is equal to negative 2, or x is equal to 1. Now, they want the coordinates of a and b, not just x. So you need to figure out the y. And how do we do this? We substituted back into the original equation. So now we substitute 2x, which is minus 2 cubed, plus 3 minus 2 squared, minus 12 minus 2. And if you calculate that, you will get the answer of y equal to 20. If you do the same for 1, you will get 2, 1 cubed plus 3, 1 squared minus 12 to the 1. If you plug that into your calculator, you should get the answer of negative 7. Now you can work out your coordinates. Make sure that you are choosing the correct coordinates for the correct values. As you can see, coordinate A has a negative x and a positive y. Therefore, it makes sense that this minus 2 and 20 is your A value. This B has a negative y but a positive x. Therefore, it makes sense that this will be your B value at 1 and minus 7. Moving on now to question 9.2. We are asked to determine for which values will f be concave up. Now to determine this, we are going to have to do our second derivative, which means we take our answer from question 9.1. This answer of 6x squared plus 6x minus 12, and we treat it exactly the same and do the derivative again. And to indicate this, you say f dot, and you do 2 lines of x. Now we treat it exactly the same, and we say 2 times 6 is 12, 2 minus 1 is 1, plus 1 times 6 is 6, x gets dropped, and 12 is eliminated because there is no x with it. Now we say we want concave up. So what values will make x greater than 0? If you wanted concave down, you would have less than 0, but in this question they ask which values of x will be concave up. Now, how do we solve? We solve as per normal and treat the greater than sign just like an equal sign. We have 12x, we take our 6 across and change its sign. Now dividing both sides by 12, you'll have x is greater than negative a half. and that would be your final answer. That will be your final answer. Moving on now, we go to question 9.3. Question 9.3 asks that we determine the equation of the tangent of f at c is 2 and 4. How we determine the equation of the tangents is we have to calculate the gradient, and by calculating the gradient you need the derivative, which we have luckily already worked out. We know that the derivative of f of x is equal to 6x squared plus 6x minus 12. Now, if we sub in this 2 into these x's, we can get the gradient. So, 2 squared plus 6 times 2 minus 12. If you look at that, that will be 6 times 4, 24, plus 12 minus 12 equals 24. Therefore, that is your gradient. This is always true. The derivative, if you substitute in your 2, you will get your gradient. Now we need to figure out the equation of the tangent. How do we figure out our equation? Well, we know that if we say y1 minus y2 is equal to mx1 minus x2, and we have got values for x and y over here. Therefore, y1 minus 4 is equal to 24, x1 minus 2. So now y1 is equal to 24 times x1, so 24x. 24 times 2 will give you 48, plus 4 will give you minus 48, plus 4 will give you minus 44. And that will be the equation for the tangent to the point at C. Moving on now to question 10. We have been told that the graph f of x equal to ax cubed plus bx squared plus cx plus d has 2 turning points, and this is the standard form for the graph. We also have been told that f of 2 is equal to 0. What is this telling us? This is saying that our y is 0 when x is 2. Therefore, one of our x-intercepts is equal to 2. The second point here is telling us that the x-axis is a tangent to the graph of f at x is equal to minus 1. This is saying that the graph, the x-axis of the graph, touches a graph at a point and never again. This means that one of our turning points, TP1, is x is equal to minus 1. Next, they tell us that the derivative of x at 1 is equal to 0. This is telling us that other turning points, because remember, how we determine turning points is by solving for the derivative and making y equal to 0. This is saying y is equal to 0 at the derivative of x. Therefore, turning point 2 is equal to x is equal to 1. Next, they are telling us that the shape of the graph, f of is a half, is greater than 0, indicating the shape of the graph to be like that. Now, you must sketch a graph showing all the correct information that they have told you, making it rough but indicating points that are given. You know that the graph comes down, touches at a point, goes back up, turns and goes down, as is the normal shape of that graph. You know that turning point 1 is 1 and negative 1. Negative 1 will be here, 1 will be here, the turning points. Now, you also know that the x-intercept is equal to 2. You can write the full coordinates just to make sure. And then that is all the information they require you to include in that diagram. Make sure to clearly label it so that they know what you were indicating. This is your y-axis, this is your x-axis, and it's the graph of f of x. We now move on to question 10.2, which is no longer functions, and is a problem-solving question. O is the center of a semicircle passing through A, B, C, and D with the radius equaling x minus x squared, where x is less than 1 but greater than 0. So if we draw this out, we have a semicircle with a triangle that is right-angled triangle. And they want to know what the area of this part is. That colored in part, they want to know the area. So since you have a right-angled triangle, a right-angled triangle means that this is 90 degrees, which means it is actually 1/4. That triangle is 1/4 of the circle. So to figure this out, they tell you what the answer is, and they ask you to prove that the area is given by this answer. So taking alone this part of the 90-degree triangle and that is 1/4 of the circle, since it is 90 degrees. So the area of this segment here is 1/4 of the entire circle. Therefore, you know the area of this segment is 1/4 of the area of a normal circle. So what is the area of a circle? It's equal to pi. So the area, okay, let's do this. The area of a circle is equal to pi r squared. You know that the area you're dealing with is 1/4 of pi, and r is given to you as x minus x squared, and that is all squared. So that is the area of the entire portion you're dealing with. But they didn't ask you for the area of the entire portion. They asked you of the area just of the shaded region. So now you want to exclude the area of the triangle. And what is the area of a triangle? It is equal to half base times height. But since our base and height are the same, it is the equivalent of saying half base times half your height. It is the equivalent of saying x minus x squared. So that one thing times the same is the same as saying squared. Now we need to put these together and subtract the total from the triangle to get the shaded region. So the area of the shaded region is equal to 1/4 pi x minus x squared, all squared, minus half x minus x squared. Now, we see that we have quite a lot of similarity here. We have these two terms that are identical. If you put the square there, sorry. These two terms are now identical. So we could take them out as a common factor. X squared, all squared together, and then a common factor of 1 over 4 pi minus a half. Now, how can we deal with those two fractions if they're different denominators? How can we deal with them together? Well, if we times that by 2 and times that by 2, you will have 2 over 4, which is the same thing, but now can be worked with that 1 over 4. So now, if we say x minus x squared times 1 over 4 pi minus, since it's a common denominator, they can all have the same denominator, minus 2. So now, the equation we were looking for initially to prove looked like this. Pi minus 2 over 4 times x to the 4 minus 2x3 plus x squared. So now ours does not look exactly the same yet, but we just need to do a bit more simplifying. So if we switch the order, drop the 1, pi minus 2 over 4 times, and now we just need to FOIL these two. You would get x to the 4 minus 2x3 plus x squared. If you simply FOIL those brackets, you would have identical answers, and therefore you have proved that the area is made by that. I hope that all made sense. And now we move on to question 10.2.2. Determine the value of x for which the shaded area will be a maximum. So if you have the area already, now you just need to solve for the maximum. How did we solve for maximums? You use the derivative. So now if we say that the area is equal to pi minus 2 over 4, x to the 4 minus 2x cubed plus x squared, what would be the derivative of this? Well, there's no x's in this first term, so that entire term can be dropped. Then we're just dealing with this second bracket. Now, 4 times 1 is 4. 4 minus 1 is 3, minus 3 times 2 is 6, x. 3 minus 1 is 2, plus 2 times 1 is 2, x. 2 minus 1 is 1, which you do not have to write. Now you just need to solve for x to figure out what could be the possible answer. Here, again, we can take out a common factor to make it easier to solve. If we take out a common factor of 2x, we can have 2x squared minus 3x plus 1. Now it will be easier to solve and make two brackets. We do our normal two brackets, 2x as one answer and x as the other answer. Here, 1 can only have one answer, and you know that the signs will be the same because it is a positive. However, this is a negative, therefore both of them have to be negatives. 2x minus 1, x minus 1, and since they are the same, it does not matter which bracket each is put into. Now to figure out the maximum, you let that equal 0, therefore x can be equal to 0, x can be equal to a half, or x can be equal to 1. And those are the answers for each of these individual brackets. Now, not all of those answers are valid because they told you that x is less than 0 and x is greater than 1. X is less than 1 and x is greater than 0. So that cannot be the answer. And that cannot be the answer since they told you that already previously that x is less than 1 but greater than 0. Therefore, x is equal to a half. Moving on now to question 11, which is probability, which is often quite a difficult section, but we will see if we can break it down to make it slightly more digestible. So question 11 is looking at probability with two events, A and B, such that A and B are independent, meaning that A and B have no connection in between. You cannot be both A and B. So A and B are independent events. They tell you that the probability of not A is 0.4 and the probability of B is 0.3. Now the question 11 asks you, 11.1, asks you to calculate the probability of A and B. This means you need to calculate, first of all, what the probability of A is, because you are given the probability of B, but the probability of not A. So how would you figure out not A? If you were to draw this in a Venn diagram to make it understandable, you would see that we have A and B and other. So other is in the box. A and B have no interlinking bits. So B is 0.3 and not A is equal to B plus this outer box, which we could call C. So B plus C would be equal to 0.4, and therefore this outer C bit would be 0.1, because it would be 0.3 plus C is equal to 0.4, and if you did maths, you would get 0.1 over there. So now this whole entire system, though, has to equal 1, which means that the missing bit A would be 0.6. So over here, we could write that the probability of A is equal to 0.6. Now, that's not what the question asked. The question asked for us to calculate the probability of A and B. But now we have the probability of A, and to get and, we'd multiply by the probability of B. This means you would have 0.6 times 0.3. Therefore, the probability of A and B would be 0.18, and that would be your answer. Moving on now to question 11.2. They have a long explanation saying that there's a survey among 150 learners where the following observations are made, and they give you a very extensive and very useful Venn diagram. Over here, we can fill it in and make sure we understand everything. The H is for hockey, the D for debating, and the C for chess. 0.24 only play hockey, which we can see here. Hockey and debating but not chess is 0.14 over here, we can see, and then there. Debating and chess but not hockey would be 0.12. Hockey and chess but not debating 0.02. The probability that a learner selected at random participates in at least one activity is 0.4. So the probability that they're doing one of these at least is 0.4. And the probability, and then there are 15 learners that participate in all three activities. So this A section is 15 learners. So the middle part is the interlinking, saying they do H, D, and C. The number of learners participating in only debating is the same as learners participating in only chess. So this D value, as you can see, they've labeled it with the same number B and B because they are the same value. Now let's look at the questions. 11.2.1 asks us now to determine the probability of a learner selected at random participating in all 3 activities. So in the information, they told us that 15 learners participate in all 3 activities. And we were also told that there is 150 learners in total. Therefore, the probability of 15 over 150 is equal to 0,1 or 10%. So the answer there would be 0.1. Moving on to 11.2.2, they want you to determine M, the probability that a learner selected at random does not participate in any of the activities. So this outside thing here, M, is what they want you to calculate, remembering that this entire system has to add up to 1, or a probability of 100. So all of these values together, plus this M value, would have to equal 1, or 100%. They told you that there is a 0.7% chance that someone participates in at least one activity. Therefore, this outside piece will be your 100 minus your 0.7 to equal 1. So how we would write that would be that M is equal to 1 minus 0.7, and therefore M is equal to 0.3. And there would be your answer. It might be helpful to write it down on the Venn diagram because you could use it later. Moving on to 11.2.3, this question now asks, how many learners play only chess? So now they want you to figure out this value for B here, and they're asking about chess specifically. So now, how many learners only play chess? Well, we know that the total is 1. We also know that, so if you work out everything, the one value you don't know will give you your answer. So we know that the total system has 1. We know that 0.3 does not play anything. We also know that 0.24 only play hockey. We also know that 0.14 plays hockey and debating, but not chess. We also know that 0.02 do chess and hockey. We also know that 0.1 does all 3, and 0.12 does debating and chess. This leaves us with some amount that doesn't include just debating and just chess. If you calculate this amount and you see what is left, you will be left with 2b equaling 0,08 chance. Then we divide both sides by 2, and b should be equal to 0.04. So here, all we did is take the total possibility and minus all the possibilities we know to get the possibility that is unknown in the situation. You could do the same by just trying to add it up all to 1, but adding or minusing here is not relevant as long as you understand the concept that the whole system is equal to 1. So if you took all the parts, the 0.3, 0.2, 0.14, 0.1 here, and 0.2, with these 2 extras should all add up to 1. And therefore, that is what we have done here. All right, moving on now to 11.3.1. This is a new question that now asks that, and they tell you, a 3-digit number is made up by using 3 randomly selected digits from 0 to 9 with no repetition. Sorry. All right, and they ask for you to determine the total number of possible 3-digit numbers that can form 100. It has to be greater than 100, and it is a 3-digit number. So now if we look at this, you have 3 placeholders for what your number should be. It has to be 3 digits between 0 and 9, but it also has to be greater than 100. So you have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9 as your options. But in the first digit, you cannot have 0 as an option, because if 0 is your first digit and 2 is your second digit and 4 is a third digit, that gives you 24, which is less than 100. So that cannot be a viable answer. 0 can never be put in the first digit placeholder because the answer has to be greater than 100. That is important. So now you have one less option in this first placeholder compared to the others. Therefore, you have 8 options in this first one, times 9 options in the second, times 9 options in the third. If you add this all together, you should get your answer of 648 options. 648 numbers that can possibly be the correct answer, greater than 100, but that goes with your requirements using numbers 0 to 9. The reason this is lower than all the options is because the numbers cannot be repeated, and that's why even though you have 10 options, you times by 9, and in the first one you cannot use you cannot use 0, and therefore you have 8 options. Moving on to 11.3.2, you are told that using the same set of numbers, so 0 to 9, with no repeating, you need to find a 3-digit number greater than 600, but it must also be even. And what does this affect? This even affects the last digit, which can only be 0, 2, 4, 6, or 8. But now, we also know that this means the first digit has to be 6, 7, 8, or 9. It is now also restricted. However, there is no restriction with the middle number, except for the fact that there cannot be any repetition. So if we look at this, if our first digit is 6, that means our last digit, we have one option here. Our second one can be any of the 8 other options, because there are 2 other numbers there, so you cannot repeat those, so you only have 8 options. But this last digit, usually you would have 1, 2, 3, 4, 5 options, but you said for sure that the first one is 6, which means you cannot use this 6 here. Therefore, you only have 4 options, right? So you have 1 times 8 times 4. The same could be said for when 8 is your first option. You only have 1. Then again, you'll have 8, and then again, you'll have 4. So this would be 1 times 8 times 4. But now, if you have your 7 or 9 as your first option, you will have 1 times 8 times 5, and 1 times 8 times 5 if it is 7 or 9. This is the equivalent of saying 2 times 8 times 4, and 1 and 2 times 8 times 5. So this is for your odd numbers, your 7 and your 9. And this is for your even first numbers, your 6 and 8. If you add these up together, 2 times 8 times 4 is equal to 64. 2 times 8 times 5 is equal to 80. In total, 64 plus 80 is equal to 144 options. I hope that all made sense and that this paper all made sense to you. Yeah.